All right, lesson 3.2, linear regression. There's going to be a lot on this one about how to enter things in the calculator. Probably the first time we've done some of the statistics on here, so maybe a little bit longer going through the keystrokes, but try to keep it as short and sweet as possible. All right, so linear regression, let's just kind of define a couple words here. Linear regression is used to see if two variables are related, often used in stats with applications in business, healthcare, many other fields. In business, you might want to look at how much money you've spent in advertising versus how much your sales are, and you track that over time. And if you can model that with some sort of an equation, you could predict how much money you're going to make in the future. Or if I spent this much more money on advertisements, how much more money could I bring in? In healthcare, it might be related to like the amount of milligrams of medicine you take compared to like maybe your white blood cells or something of that effect. There's other types of regressions, but we're going to focus on linear relationships because that's the unit we're kind of in right now. So we collect data, we organize it into a table, we then create a scatter plot, which there's some examples of that down below. And our goal is to draw a trend line, a line of best fit that represents the data. So just kind of looking down here below, you might just kind of gradually say, well, that might be a good best fit line. And maybe here, this one kind of looks like it represents most of the points. And then the other one, there's no correlation there because there's just dots everywhere. But hopefully we can get a best fit line and we can write an equation for it that allows us to make some predictions. Correlation, this is another word we probably ought to kind of define. Correlation is the strength and the direction of the linear relationship. And the three types are below. So positive correlation means the dots are going up and to the right. As one variable goes up, the other one goes up. Negative would be coming down. And then no correlation, like we might do, say we were going to look at your height and your GPA. There's probably not a very strong correlation between how tall you are and your grade point average. There's going to be tall people with high GPAs, low GPAs, and vice versa for short people. So let's look at an example so we can kind of sink our teeth into this and get rolling. So gas mileage and horsepower of cars. I found this data set that had some randomly selected cars that showed their horsepower, showed their gas mileage. And let's see if there's a relationship between gas mileage and horsepower. So here it says let X represent the horsepower and Y is going to represent mileage. So X is here, Y is there. And we want to try to plot this on the graph and then come up with an equation that models this data. And we're going to do this one by hand. And then the next example, we're going to do the same set of data with a graphing calculator to kind of show you the difference between the two. All right, well, first off, I have a graph here, my little piece of graph paper, and I need to kind of get all this data to fit on here. So what I want to do is I'm going to look at my X values, and it looks like all of these X values, it looks like we got to stay between 100 and 255. So on the X-axis, it might not make sense to start at 0 because none of the numbers are until 100. So I might actually put like a little break in the graph, and I might start 100 right here. And then, I don't know, maybe we can go by tens. We'll see. We may go off the graph a little bit, but so 110, 120, 130, 140, 150, 160, 170, 180, 190, 200. That gets most of the data. It looks like we do have this 255, so I might just extend this graph out a little bit. Otherwise, I think everything is going to be kind of smashed. And this is real life. Sometimes you do a graph and you got to monkey with it a little bit. All right, so 250 would be somewhere 2, 10, 20, 30, 40. 250 will be right over here. And then going up the side, those numbers, the Y's, it looks like our smallest Y is 13. And we go all the way up to 35. So we got to stay between 13 and 35. So we could probably start at 0 and we could go up to 40. So I don't know, maybe counting by 5s would be the easiest. So 5, 10, 15, 20, 30, 40. That ought to be somewhat decent. You could have you could have went by 4s or went by whatever, other numbers, but I'm just going to kind of try to keep it simple. So let's put these dots on the graph here real quick. So horsepower of 175 and gas mileage of 22. So I believe that dot is going to go like right in here. Then we got to do 255 goes up to 13. So that might be around in here somewhere. 140 to 25. That's right perfectly there. 65 and 18, which would be in this area. 115 and 32. Maybe right up in there. 120 and 28. 120 and 28 will be right in here. 190 and 15. 180 and 21. 110 and 35. And then finally 125 and 30. 125 and 30. There, so we got some dots on there. You know, that 250 is kind of chilling way over there to the edge. But I think I could kind of draw, you know, maybe a line that best goes through that data. And what I'd really like to do is I'd like to kind of hit 2 points if I could. So, I don't know, let's go through and let's try to hit a couple of points here. And maybe, let's see. I don't know. What do I have? I got the 35. Well, I don't. Maybe if we do something like this. I'm going to just try to kind of guesstimate. And I think that maybe if I just kind of connect this first dot with this dot over here, let's see how that does, if that kind of somewhat connects the data. Okay. That's not too bad. That's a decent line that kind of goes through the data. But the thing is, just get it through any 2 points, and I think we'll be good to go. We'd at least be able to write ourselves an equation. I don't think that's a horrible line, probably not the best line. I might have been able to lower it a little bit, but let's just roll with it. Let's just see what shakes out. So when I roll with this line, and I have an equation I want to write, remember, to write an equation, we need to have 2 points. That way we can get a slope from it. So that point right there was, I believe, this point, 115, 32. And then the other point I chose was way over here, which was at 255, 13. Well, I think we're all set where we can kind of get our slope here. So the first thing I'm going to do is I'm going to calculate the slope. And remember, I need a slope and a point to write an equation. So the slope is change in y over the change in x. So when I subtract the y's, I got 32 minus 13. And when I do the x's, I have 115 minus 255. So let's see what that comes out to be. 32 minus 13, well, that's 19. Over, and that's what, negative 140? So there's my slope, and since this is like an application problem, we're going to go ahead and we're going to use decimals. So I'm going to divide this out. I know normally we don't, but we're going to do it here. Negative 19 divided by negative 140 is, I'm getting negative 0.1357, blah, 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 blah. Let's just round that, and let's just call that negative 0.14. All right, so I'm going to go, slope is negative 0.14. So this is my m, or this is my slope. And so now to write an equation, I need to get my starter equation. So y equals negative 0.14x plus b. And just like we've done in previous lessons, I'm going to pick one of these 2 points. maybe I'm going to pick this x and this y to plug in there. So 32 equals negative 0.14 times 115. We don't know our y-intercept right now, so let's calculate it. So we have 32 and negative 0.14 times 115 is negative 16.1 plus b. Well, now to get b by itself, I'm going to add that 16.1 to both sides, and I get 48.1. So I think I have an equation now. I'm going to go back up here, and I'm going to get rid of my b, because I know what it is. It's 48.1. And I think I have a best fit line. At least just according to my eyeballs. And I kind of just picked two dots and just kind of drew a line through there. I don't know if it's the best one statistically, but at least it gives us an approximation of this. Now you might look at this and you might be like, well, wait a minute, Kraft. How in the world could our y-intercept be 48 when it looks like this line right here is not going to cross my graph anywhere near 48? And that's where you got to be careful, because remember that we had this break in the graph. This graph started at almost 100. It actually started at 90. So you'd almost have to kind of pretend that this thing is actually going to go backwards a lot further. And so this line is actually going to keep going, and it probably will cross up closer to 48. But we kind of zoomed in on a section of a graph, so I just thought I'd throw that out there. Now, as you can see, that's a lot of work. We had to graph the dots, we had to draw a line, we had to write the equation by getting the slope and solving for b. So we're going to try to do this using the graphing calculator to the right. So let's go to the next page. And we have the same set of data, and it says now let's use the graphing calculator to perform our linear regression. This is going to give us the best fit line, meaning the calculator is going to use statistics to find the perfect line, and it's going to come up with what's called a correlation coefficient, this R value, and I'll talk more about this R value here in a minute, but we're going to get an R value to tell us how tight is the data, how good of a fit, how close are all the dots really to the line. So here we go. So step one, it says you can use a graphing calculator to perform linear regression, but to do this, we need to first turn on this diagnostic mode. So what we're going to do is we're going to go over to our calculator. I'm going to turn it on. And right now I need to press second 0. So I'm going to hit the second key and the 0 key, which is the catalog. Now the catalog is alphabetical. It starts with the A's. So I'm going to use my down arrow, and I got to go all the way to the D's. Takes a little bit, but I'm going to go all the way until I see diagnostic on, and I'm going to hit enter. And it's blinking, and I hit enter again, and it says, okay, done. So step one, we have our diagnostic on. We should never have to do that again. It should just stay on now in our calculator. So now step two, to enter the data into the lists, we need to press the stat button. So I'm going to go over here, the second row, and I'm going to click stat. And I get this come up, it says edit calc test. Well, we want to edit. So it's already on the 1, so I'm going to hit enter. And you have a list, and this list is kind of like, you can think of it as where your X and your Y table live. So if you'd like to, you could kind of think of, this is your X, make that a little bigger. This is your X column, and this is your Y column. That's really kind of what it means. And I have some values in there that I need to get rid of. Yours probably doesn't. So if you do have some numbers in there already, because someone else used your calculator, arrow all the way up to the top where it says L1 and hit clear, and then hit enter, and it'll wipe that column out. And I'm going to arrow over to the left-hand column and go up to the top. And I'm going to hit clear, and I'm going to hit enter to clear that column out. So now we can start entering some values. Usually I think it's easier if you enter all the X's and then do all the Y's. That way you're not going back and forth. You can just hit enter. So here we go. I'm going to enter 175, enter, and it'll go down 255, enter, 140, 165, 115. Here's where you may want to just do this on your own and speed up the video, but maybe you'll stick with me. 190, enter. 180, enter. Hopefully I don't screw these up. 110, enter. If you take AP Stats, you're going to be doing this a lot in AP Stats. So I believe I have all of my X's in. Now I'm going to arrow over, and it should jump to the top of the Y's. And now I got to start with 22 and go down. So 22, 13, 25, 18, 32, 28, enter, 15, enter, 21, enter, 35, enter, and 30, enter. Sweet. Now you should notice that you have the exact same amount in both columns. Otherwise you'll get a dim error, a dimension error, saying that, hey, you have a different number of X's and Y's. But I think we're good to go. All right, so we've entered all of our values. So step 2 is done. Now to make the calculator go to work for us. To find the correlation coefficient and interpret the slope and blah, 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 we're going to enter the data into our list, which we've done. And then we need to select linear regression. So I'm going to go back to the Stat menu. I'm going to go to Stat. And in Edits where I created the list, I'm going to go over to Calc. And we're going to calculate number 4, LinReg, linear regression. And you'll notice it's in the form of a line. Instead of mx plus b, it's ax plus b. I don't know why. But we click that, and it's saying, hey, do you want to look at list 1 and 2? We're like, yep, hit enter. Hit enter. Enter. Calculate. Boom. And what it did was it just spit out a list of values. And so I'm going to write those in over here. It says the equation expressed in the form of y equals ax plus b. Our a value is negative 0.1498, blah, blah, blah. I'm not going to write all that stuff down. That's enough. Our b value is 47.5. And our r value, we're not going to really use r squared right now. That's another statistical thing we can look at. But we're going to look at our r value is negative 0.91. And I'm going to talk about that here in a second. But right now I just want to look at, we have an equation. So if we think about our equation, it's y equals negative. If we wanted to round that, we could round that negative 0.149 to maybe 0.15 x. And then our y-intercept is b. Maybe we just use 47.5. So that's pretty doggone close to what we did by hand. But this is statistically like super accurate. This is the best possible line we could have drew. And if I wanted to, if we wanted to actually see our scatter plot, what I could do now, so we kind of have this. What I could do now is I could come back over here to my calculator and I could go to, you see where it's normally y equals, and that's where we put in, you know, all of our values to graph a line. Well, if I hit second y equals, I go to stat plot. And right now, stat plot, we're under stat plot number 1. And I want to actually turn that on. So I'm going to hit enter. And it turns it on. So hit enter. And then we can tell it what type we want. Well, I think right now it's already selected as a scatter plot. And you don't really need to mess with the other stuff. This is just saying, are we going to use L1 and L2? Yes. Do we want our dots to be bigger? I like the bigger dots better. And now I'm going to hit graph. And unfortunately, I don't see our data because our window, we're kind of in a crazy window right now. We're only going from negative 10 to 10, and our data didn't really fit there. So if you remember, our x's went from somewhere in the neighborhood of 100 all the way up to, I'll go a little past 255. I'll go to 260. And maybe we go by tens. And then our y's, we went from 0 up to 40, I believe. And I think we made those go by 5s when we did it by hand. So now let's graph that. And now I can see my scatter plot. All of those dots that we did, we can kind of see our scatter plot and how it compares. Now I'm kind of curious. I kind of wondered that line that we just had, that we wrote down. It was the negative 0.15x and 47.5. I kind of want to see what that line looks like with the dots. You don't normally have to, but I just kind of want to see it. So I'm going to go to y equals, and I'm going to type in negative 0.15x plus 47.5, and let's hit enter. And let's graph that. So that's statistically the very best line that could go through there. I think my line was a little bit off. My line was a little bit higher. Just me kind of ballparking it. I think when I did my line, I ended up going from like this dot through that dot, so I was pretty close, but a little bit off. All right, let's go down and let's just see what else this asks us. I think we're pretty close to being done. So we have the equation that I guess I can write back in here. So the equation y equals negative 0.15x plus 47.5 is the best fit line. One thing that we kind of want to understand here is the slope. In this case, what does the slope mean? Like, how do you, and the SAT might ask you, like, how do you interpret the slope? Well, this slope right here basically says that since it's negative, and we're talking about the y values here, it looks like our gas mileage drops, okay, 0.15 miles per gallon, 0.15 mpg for every 1 unit of horsepower. That's how you kind of interpret that. Every time you add a horsepower, you drop down about 0.15. So if we kind of magnified that and we kind of multiplied by 10, basically you lose 1.5 miles per gallon for every increase of 10 horsepower. So the more horsepower your car has in general, the less the gas mileage is going to be. So that would be an interpretation of what that slope represents. Now, last thing about the R values. If you have a set of data that's like really loose, all right, and for instance, over here, our data was pretty doggone tight. If you remember our R value, the R value for this equation was negative 0.91, all right? If you're at negative 1, you're at a perfect correlation. Like it's a formula. There's no, every dot is exactly on the line. Negative 0.9 is pretty doggone tight. That's a very tight set of data. So on here they have a negative 0.95, really tight. A negative 0.6 would be like, yeah, it's kind of going down, but the points are really far away from the line. 0 means there's no correlation at all. It's just random. And then you have like a really loose one going up, or you really have a tight one going up. All right? So positive R values are increasing, negative values are decreasing, and the closer you get to 1, the tighter those dots fit to the line, and the better your model is for the data. All right, I know these notes were a little bit long, but hopefully this lets you have a little bit better understanding of what the practice is going to be about. See you.